Okay, welcome to today's webinar, Getting the Most Out of Coreform Cubit. I'm Matt Cedarberg, the Chief Strategy Officer at Coreform, and Greg Vernon, Coreform's Director of Product, will be leading you through the webinar today. The hope is coming out of this webinar that you'll be able to take your use of Coreform Cubit to the next level and have it be an even more effective tool for creating hex and tet meshes to create geometry for CFD and FEA.
So as Matt said, today we wanted to share with you briefly was just some updates with Coreform Cubit and a review of some of the features or high value features in Cubit to let you get the maximum value out of it. Just an overview of Coreform Cubit. It's a meshing software based that meshes CAD geometries. And so it has a full suite of CAD import and cleanup capabilities, as well as in a workflows for semi-automated hex meshing, though it also does support 2D meshes, quads and tris, 1D elements like beams and bars, as well as tetrahedral meshes and wedges. And Cubit is kind of based on giving the maximum amount of power and control to the user. And that includes both in things that allow you to get high quality meshes or meshes exactly with the properties that you wish, as well as Python and scriptability for automation. So as I mentioned, we're going to talk a little bit about what's new with the latest version of Coreform Cubit 2024.8, as well as some of the services that we provide, including data translators, and then our forum. So what's new in Coreform Cubit 2024.8? The highlights are that we've improved our Python documentation, especially in particular for new users to Coreform Cubit and new users to the Python interface. We also have a new workflow for our customers in the neutronics field, particularly with being able to rapidly import OpenMC geometries into Coreform Cubit, as well as integration into our isogeometric analysis workflows based on our other product, Coreform Flex. The first thing I wanted to do was talk about our improved Python documentation. So one of the things that what we've done here is to clean up or make simpler for users. We've given a better introduction to how to use the Coreform Cubit Python API, as well as in providing really a focused view on the different forms of the application program interface or API. We recommend that users use the method-based API, which is primarily where you're using Coreform Cubit to pass strings through the CMD method into Coreform Cubit, rather than its object-oriented API. And so that should simplify things for new users and cause less mistakes when using the object-based API first. Since most Python users think in object-oriented programming, but really you want to be using methods. Furthermore, the full documentation of the API, which is really a C++ API, is available still in the appendix under the Coreform Cubit API, which then provides the full functionality that's available, but in C++ form. So you can see that these methods are really C++. Some of them or most of them are available in Python through a technology called Swig, but you can see that these are returning C++ terminologies like a standard string, void, references, and pointers, stuff like that. So this is the old documentation that requires a bit more understanding of C++ and programming for users, and that's what we've simplified. And just to recap as well, just to remind that Coreform Cubit is perhaps unique in that it supports running Python both in the actual Coreform Cubit GUI application. We can use a shebang in the command line, which is this pound exclamation point in Python, or pound exclamation Cubit to get back to the Cubit command language. But now we're in Python and we can do everything like, say, import NumPy right directly within our Coreform Cubit instance, or through an external Python environment. So in this case, I've just installed on my system Python 3.12. From here, I can just append the path to the Coreform Cubit module and then import Cubit, and then I can run Cubit inside of my Python API or my external Python environment. So especially in today's world of AI really being a big part of a lot of workflows, being able to import Qubit into your custom setup of your Python environment is valuable. So that can work and right alongside any of your custom Python environments. And then we have two new neutronics workflows. I'm going to have Matt talk about the integration with the OpenMC um, CAD interface, which uses constructive solid geometry or CSG, as well as then a new command called sweep along curve with twist that's used by customers to produce geometries for like accelerators. And I'll show a demo of that as well.
One of the main places that we see Qubit used is through a lot of different solvers, some of which may or may not have their own dedicated preprocessor. So Qubit's often used when someone just needs a great way to create a high quality mesh. And in the field of neutronics, for both vision and fusion, we've seen a lot of increased adoption lately. OpenMC is an open source Monte Carlo neutronics code, and there's ways to create designs and models directly in that using a technique called constructive solid geometry. With this new enhancement, we can now import those into Qubit so they can be visualized alongside CAD geometry for a number of different workflows based on neutronics. And if this is an area of interest to you, we have a lot more details on our forum, and we're happy to engage and share some more examples. We actually have a couple of webinars that will be coming up next month going into this in detail. But just a couple of examples, if you go to the next slide, Greg. So yeah, this currently supports all of the different ways of creating CSG geometry in OpenMC. Going to go to the next page. Here's some examples of the types of complexity that we can handle compared to the visualization in Qubit compared to the OpenMC plotter. If you go to the next stage, the next slide, then it shows this in 3D. And also one of the benefits of this is that you can isolate small parts of the CSG model. So you can check for overlaps or how the CAD geometry will fit alongside the CSG geometry.
And again, one of the things I wanted to point out just on that last slide, again, being able to import Qubit alongside your OpenMC, again, because you can run Qubit in that external Python, or you could add OpenMC to your Qubit or to the Qubit GUI. That's really like the power of Qubit and Qubit Python coming to bear. I also mentioned this new command we specifically designed it for stellarators. So this is kind of the shape of plasma in a stellarator. But you may find this command useful for other geometries. In the GUI, there's now this additional option for sweeping a surface along a curve to include a total twist angle. And so in this case, being able to twist this, there were 3 surfaces here, being able to twist each of them around that curve and with that twist. We also mentioned at the start that one of the other big workflow things that we've supported now is Coreform Cubit within our isogeometric analysis workflow in Coreform Flex. Coreform Flex has a native file format that it reads and writes, which is called the Coreform Flex file format. Its extension is .cf. And this export, as we see here, there's 2 workflows that Coreform Flex supports both body fit approaches as well as immersed approaches or partially immersed approaches. They're both supported by Coreform Cubit. In the case of body fit meshes, you can build your mesh in Coreform Cubit and export it. And then our Coreform Flex can then run simulation on that body fitted hex mesh. Alternatively, you can do model prep in Coreform Cubit, cleaning up CAD geometry, assigning surfaces for boundary conditions, because Coreform Cubit is much more mature in terms of being able to automatically identify surfaces and modify geometry. So you may find some of that model prep easier in Coreform Cubit and then come over to Coreform Flex when you're ready to just immerse your geometry and assign the simulation parameters. Um, and then being able to visualize the results out in pair view. But this is now fully supported from Coreform Cubit to Coreform Flex. We also support surfaces for Coreform Cubit, including training either via Zoom or in person. We've also developed Python scripts for folks who are interested in getting started with that or have unique applications. On the right is one of those examples that's available in our forum. We have a short link here, coreform.com/stent. I'll show that briefly in a moment. Matching services, customizing the GUI, developing new features, or integrating Coreform Cubit with your solvers that you might have in-house. And just to show an example of this Python script development and our forum. So if you click that link or follow this link at coreform.com/stent, you'll find this forum thread where the customer had mesh data out from a third-party solver, and they wanted to be able to reconstruct wires for a stent. And so again, using Coreform Cubit, we're able to import third-party libraries like the Network X module, and then integrate those two things together to then eventually be able to create the mesh for them. Additionally, one of the things you may find is the importing of CAD geometry, that we have native CAD importers for several different file format, including SolidWorks, Creo, and Parasolid. There are native file importers like Step and IGES. I just want to motivate this a little bit that oftentimes, especially with IGES, that native formats oftentimes have issues just in the translation that whenever you're going from a native format to a neutral format, that data is oftentimes lost just even in that first translation, as well as in the second translation. And so we find customers oftentimes have more success if they're using the native format to do their imports. But just to motivate this a little bit further, that even if you do have, in this case, this is the IGES file, where you can see there are some things like some free curves, or that these bounding surfaces for these holes are damaged. There is the ability in Cubit, again, maximum power to the user, to come through and specifically clean up your geometry so that you can then reconstruct quality CAD. So in this case, being able to delete those surfaces and then create new surfaces. And if you do that for all of these holes, you can then reconstruct, add the chamfers, do the removals. You can reconstruct that this geometry. So it has the full power for you to be able to do that, although that's obviously a very manual process. Whereas instead, being able to just natively import your CAD geometry in its native format, oftentimes, as you can see here, has almost no issues or fewer issues. So we highly recommend, if you're interested in Cubit and you use a CAD software in-house, that you would investigate our native CAD translators. And then finally, we recommend, as we showed earlier, to use the Coreform forum to either share or view other people's approaches with meshing, getting help with errors or reporting bugs that you found, accessing Python scripts that we find that are useful that we share, tips and tricks, or requesting features. We track the forum closely throughout the day. So if you want to get a hold of us, the forum is a really great place to get a hold of us and the community. I think I'll show real quick. I know I showed the other example, but just another question of someone who's new to hex meshing and was interested in trying to reproduce a mesh, and then being able to get direct feedback from Coreform as to how to create that mesh best.
Great, great. Thank you so much. If you didn't mind, while we wait for a few questions, can you go to the webinar page on our website? So
Sure.
the motivation for this webinar is just for us to kind of pull together some best practices that we've seen as customers have adopted Qubit, ways that we've been able to accelerate that adoption through providing some services or introducing CAD translators or helping them engage with the form. We do have a rich library of recorded webinars that are searchable here across all sorts of topics. So if you even just type with like Python, for instance, you'll see here, then you can see all of the webinars that have to do with Python. And or different application verticals, different solvers. So there's certainly a lot of material as you advance in Qubit about tips and tricks and ways to maximize your investment. But the hope today was just to help accelerate, especially as you're looking to deepen or broaden adoption of Qubit across your organization, about ways that we can help accelerate that. Greg, thanks again for your strong preparation, and we look forward to seeing the rest of you on a later webinar.